Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. And good morning. Welcome back to AM025 Mathematics 2. Now we are in lecture 2 of 6. And for this lecture, we have two learning outcomes. The first one is this one. You want to find limit fx when x approaches a over limit gx when x approaches a when both of these limits are 0. Okay, that is the first learning outcome. And the second learning outcome is this one. We need to determine the derivative of a function fx using the first principle. So this one is the first principle. Okay, so first one here we have this one. If limits fx when x approaches a over limits gx when x approaches a, this one is 0 over 0, or we can say this one is indeterminate form, which means we cannot solve the limits. So this function is undefined when x equals to a, right? But its limit may exist. Then we need to use factorized method. Okay, so how to use factorized method? So we have two steps. So step one, we factorize the numerator and denominator. And step 2, we simplify the common factor. So let's look at example 1. Find limit if exists for limits x squared minus 9 over x minus 3 when x approaches 3. Okay, how do we solve this one? So we begin with the substitution. So we substitute here. What do we have? We have 3 squared minus 9 over 3 minus 3. And this one we will have the numerator is 0 and denominator is 0, and this one is indeterminate form. Okay, so what do we do is we need to factorize this one. So what we have here is we have limit, so x squared minus 9 over x minus 3 and x approaches 3. So we can factorize the numerator. We will have limit x plus 3 x minus 3 over x minus 3 when x approaches 3. So what we can do here is we can simplify, which is this one and this one. So we will have limit x plus 3 when x approach 3. So next step we substitute. So we have 3 plus 3 and the final answer should be 6. Then example 1. Example B, we have limit x squared minus x minus 6 over 3 minus x when x approaches 3. So what we do is, so we have equals to 3 squared minus 3 minus 6 over 3 minus 3. This one equals to 0 over 0, which means we cannot solve this one, indeterminate form. So what we need to do is we need to factorize. So when we factorize this one, what do we have is, so we have limit So we factorize the numerator. We will have x minus 3 x plus 2 divided by 3 minus x, and x approaches 3. Alright, so up here we have this one, we have x minus 3, and down here we have 3 minus x. So we need to modify a bit the numerator. So we will have limit, okay, we have minus 3 minus x, x plus 2 over 3 minus x, and x approaches 3. So now we can cancel off this one and this one. Alright, so after we cancel off, we have limit, so minus x plus 2 over, oh, no, not over, no more over, right? So we only have the minus x plus 2 when x approaches 3. So final step, we have minus 3 plus 2, and final answer should be minus 5. Then example B. Example 3, we have limit 3 plus t square minus 9 over t when t approaches 0. So what we do is we substitute t equals to 0. So we have 3 plus 0 square minus 9 over 0. So this one we will have 0 over 0. Again, this one is indeterminate form. So we need to modify this one. So how do you modify? First, we expand the numerator. Okay, so we will have limit 9 plus 60 plus t square minus 9, and this one should be over t when t approaches 0. Right, so what we do, we simplify. So if we simplify, we will have limit, okay, we cancel off 9 and 9 here, so we have 60 plus t square over t, and t approaches 0. Alright, so what we can do, we can factorize t from the numerator. So we will have limit, so we factorize t, so we have 6 plus t over t when t approaches 0. So next we can cancel off this t and this t, so we have limit 6 plus t when t approaches 0. Next step, we will substitute t equals to 0. We have 6 plus 0, so therefore final answer should be 6. Then right, example 2, if fx equals to 2x squared plus 1, determine the value of limit fx minus f2 over x minus 2 when x approaches 2 if exists. So first one, I want to find the value of f2. So how do we find f2? We substitute 2 here. So we will have f2 equals to 2 square plus 1. And we simplify this one. We'll have this one equals to 9. Okay. So next step, we substitute this one. Right. So what do we have is we have limit. So what is our fx? Our fx is 2x squared plus 1 minus f2, which is minus 9, right, over x minus 2, right? So when x approaches 2, okay, we simplify first. If we simplify, we will have limit 2x squared minus 8 over x minus 2. So when x approaches 2. Okay, so this one, if we substitute, what happened here is we'll have 2 square minus 8 over 2 minus 2. And this one is, if we solve this one, is we have 0 over 0, which is indeterminate form. So we cannot solve this one. So what we do here is we need to factorize. We need to factorize this step. Okay, so from there we will have limit. So 2x squared is, we factorize, if you factorize this one, we will have 2x minus 2 and x plus 2 over x minus 2 and x approaches 2. So what we can do here, we can simplify. So this factor and this factor. So we will have limit 2x plus 2 when x approaches 2. Okay. So next step is substitute. So if you substitute, we will have 2 plus 2. So final answer should be 8. Then example 2. The next subtopic is a derivative of a function. So in calculus, a branch of mathematics, the derivative of a function is a measurement of how the function changes when the values of its input change. The process of finding derivative of a function is called differentiation. Okay, and for this subtopic, I just want to emphasize on one important formula or calculations, which is down here. All right, this one. Okay. So by definitions, so we have f prime here, which is our derivative. So we will have limit fx plus h minus fx over h when x approaches 0. Okay, we have similar formula down here, which is down here, right? And this one is we call differentiations using the first principle. So in this subtopic, I will emphasize this formula only. Example 3, find the derivative of the following functions using the first principle. And our question A, our function is fx equals to 5x plus 4. Right? So first one, we'll write f prime x equals to limit 5x plus h plus 4 minus 5x plus 4 over h. Right? So next step, we expand this one. So no, when h approaches 0. So next time we expand this one, we will have limit. So we have 5x plus 5h plus 4 minus 5x minus 4 over h when h approaches 0. Then we simplify. So if we simplify, this one we can cancel off, this one we can cancel off, and so we only have 5h over h. So we can simplify this h. So for this one, we will have limit 5 when h approaches 0. So therefore, the final answer should be 5. Then example 3. Question B, we have y equals to 2x plus 1 multiplied by x minus 5. So first one, we expand this one. We will have 2x squared minus 10x plus x minus 5. Okay, we simplify. We will have 2x squared minus 9x minus 5. Right? So since we have this one, then we apply the first principle. So we will have f prime x. Oh no, in this case we can write dy over dx. So we will have limit, right? So careful with the substitution. We will have 2x plus h square minus 9x plus h minus 5 minus 2x square minus 9x minus 5, and this one over h when our h approaches 0. Right? So next step is we expand the numerator. We will have equals to limit. We will have 2x squared plus 4xh plus 2h squared minus 9x minus 9h minus 5 minus 2x squared plus 9x plus 5. and the whole thing is over h when our h approaches 0. So next step we simplify. So with this one we have 2x squared, we cancel off with this minus 2x squared. We have minus 9x, we have plus 9x here, then we have minus 5, we have 5 here. So now we will have limit for xh plus 2h squared minus 9h over h when your h approaches 0. Right, so next step, so all the terms we have h, we can factorize h. Right, so we have limit h, this one is 4x plus 2h minus 9 over h when h approaches 0. So next step, we can cancel this h and this h. We will have limit for x plus 2h minus 9 when h approaches 0. So final step, we substitute h with 0. So we have 4x plus 2, 0 minus 9. So therefore our final answer is 4x minus 9. Then example 4, if fx equals to 4x plus 2x squared, find f prime x from first principle. Hence calculate f prime 2 and f prime minus 2. So first one, we need to calculate. So f prime x, so we have f prime x equals to limit for x plus h plus 2x plus h square minus 4x plus 2x square over h when h approaches 0. First we expand this one, so we will have limit for x plus 4h plus 2x square plus 4xh plus 2h square minus 4x minus 2x square over h when h approaches 0. Then we simplify like 4x and 4x, and we have 2x square minus 2x square. So we have this term for h, for xh to h square. So each term has h, so we can factorize h. So here we will have limit h 4 plus 4x plus 2h over h when h approaches 0. Now we can cancel off. We will have limit 4 plus 4x plus 2h, right? When h approaches 0, next step we substitute. We will have 4 plus 4x plus 2, 0. So therefore our final answer should be 4 plus 4x. Done. So next one, we need to find f prime 2. So f prime 2 equals to 4 plus 4, 2, and this one should equal to 12. And for f prime minus 2, this one should be 4 plus 4 minus 2. This one is minus 4. Yep, done. Example 4.